Hello and welcome to another episode of Earth911's Sustainability in Your Ear. I'm Mitch Ratcliffe, your host. Hey, the future of buildings, transportation, and power, which is the name of a new book by our guest today, will define what work in the sustainable economy can look like. And so we invited the authors, Roger Duncan and Dr. Michael E. Webber, to join us for a conversation about their new book, The Future of Buildings, Transportation, and Power. Gentlemen, welcome to the show. How are you today?
Very good. Thank you for inviting us.
Thank you for having us on the show.
Thanks for an interesting book. It was a fascinating read. And I want to, start off first. Can you tell me a little about how you both came to collaborate on this project? You obviously have worked together at the University of Texas, Austin, but why the future of buildings, transportation, and power right now?
Roger, why don't you go ahead and tell the story, since this book was originally your idea?
Well, I was general manager of Austin Energy, the municipal utility for Austin, Texas. Mm-hmm. And Michael was on the Electric Utility Commission for the utility. And that's where we first really got to know each other. And when I retired from Austin Energy, Michael invited me to join him at the University of Texas at the Energy Institute. And we both had a long career and interest in the topics of this book, buildings and transportation sector and the electric power grid. And we taught a short course together for a while and decided that we wanted to turn it into this book.
So it's a propitious time to talk about the future of energy, basically where we work, how we get there, and how we power our work. What do you have in terms of advice for the incoming administration as they look to activate a climate response that's actually responsible and engaged with reality?
I think one thing we could say is that whatever they think will happen with energy probably isn't what's really going to happen. And I think that's something that President-elect Biden will recognize from when he was elected as vice president in 2008. The economy was in tatters. Natural gas and oil prices were very high. The expectation was that energy prices would be high forever. And if you look at what happened 8 years later at the end of the administration with Obama and Biden, natural gas prices and oil prices were very low, and wind and other renewables have really grown, and there was a lot that had changed in those 8 years. This time we're coming in and we've got the double whammy of COVID, the economic recession. I think the economic effects of COVID aren't fully understood yet. So there's a lot more dynamicism within his situation. He doesn't know whether he has a Republican or Democratic Senate on his side, which will maybe limit or expand the potential policy options open to him. So there's a lot of uncertainty, and we can anticipate a lot of things would change over several years of the administration. So what can you do immediately? You can really try to ramp up on R&D. Despite a lot of chatter that R&D is a waste of money by President Trump, actually it has a lot of bipartisan support. He can do some things with executive orders around re-engaging on the international stage on energy. So there's some things he can do whether he has the Senate helping him or not. And I guess I would just advise him be prepared that it might not be quite what you think. We saw so much change from 2009 to 2017 with energy. The world changed with the rise of shale gas and renewables, for example. We can anticipate there'll be some more changes looming.
Are there areas of research and development in particular that he should be focused on, though?
Well, I think that the areas in particular are ones to transform the electric grid and particularly electrification of the transportation sector. We see the broad outlines really of what we need to do in terms of mass deployment of wind and solar in the electric sector. And that's going to require new transmission facilities, upgrades to the distribution system to accommodate more solar and electric vehicles on the distribution grid. We still have research and development in batteries that need to proceed as quickly as we can so we can expand the electrification of the transportation sector. And then there are particular areas like high temperature manufacturing, which are very difficult to accomplish today without the use of fossil fuels. And the research and development into alternative materials that can be used and alternative processes in these areas could be very beneficial.
One other element, in addition to what Roger said, that we talk about in the book is just the rise of smart industry, smart buildings, smart cities. That's really the integration of data and sensors and actuators and computational capability with IT systems in our energy system. And I think that's an area for more R&D and more deployment because it offers some improvements on efficiency, but also resilience that's really useful for cities, for example. So that might be an area of opportunity as well.
So in terms of the flexibility of the grid, we have a hub and spoke model that is designed to generate power in one large location and distribute it to the edge of the network. Now, of course, we're moving towards an environment where the edge of the network may be producing power too from solar and wind and then contributing it to the grid. That requires a different way of thinking about the role of individual homes or businesses in the use of power. They might be producers and consumers. Do we need subsidies to encourage more adoption of solar and wind, or is that already being taken care of by the market?
Roger, why don't you tackle that, and then I can talk a little bit about the grid mix, if you'll tackle subsidies.
Okay, well, I think there's a combination of things. I think some subsidies that are targeted correctly would be very helpful in this transformation, but there's also things such as the proper tariffs and rate structures from the electric utilities that would be very helpful here in making this transition. As you pointed out, we're entering the day of the prosumer, so that the homeowner is both a producer and a consumer of electricity. And instead of there being a utility-customer relationship, there's really a relationship between two producers and two consumers of electricity. And there are various structures that's going to need to change to accommodate that.
Yeah, one other thing I'll say is that from my view as a professor at the University of Texas, but also working for ENGIE based in Paris, and ENGIE is an international energy company that's active in 70 countries, we build renewables all over the world. And a lot of places around the world, there are not subsidies for wind and solar, but wind and solar are still the cheapest option or the preferred option by the customer. So subsidies can be really useful for accelerating the adoption curve of those options and for helping in areas where there might be subsidies for the alternatives, like coal gets a lot of subsidies in many places, but it's not necessarily required everywhere. And in places like the United States, it's not clear that wind and solar still need subsidies to compete, but they have bipartisan support, so probably they'll be kept. Rural Republicans like the development and landowning, sort of sparsely populated areas of Iowa and that kind of thing where wind is really prominent. And urban Democrats like it as well. So we might not need the subsidies in the U.S. anymore, yet they have bipartisan support. One other comment I'll make about the grid is that the grid is changing, and that changes the dynamics of the grid. Historically, we have had variable load. We change the load. We turn lights on and off and appliances on and off throughout the course of the day. So the load varies a lot by time of day and time of year. And we ramp our power plants up and down to follow the load. We have a load following power sector. We design our power plants to respond to the load we have. Well, in the future, we might have a supply following mindset where the supply varies, wind and solar, based on weather or astronomical conditions and that kind of thing. And we might come up with a supply following system where we turn different industrial loads for data centers or water treatment or whatever it is, turn those up and down to match when the supply is available, rather than turning the power plants up and down to match when the demand is. So there might be some new capabilities in the grid to respond to
a much more dynamic environment. But that goes to what you were talking about a moment ago, which is all of the instrumentation, the measurement that we can do on the system. So that brings us back to information technology. First, I want to ask about privacy. Have you taken a look at the consequences of having all of these monitors around our use of electricity or our use of renewables versus fossil fuel? Do people need to be concerned about their privacy because this information is being shared?
Yes and no. So why don't I take a stab at this? Then Roger, as the CEO of utility, can correct anything I say that's wrong. But the answer is yes and no. There's a lot more data and a lot more tracking of what goes on in our world. The grocery store tracks what groceries you're buying, and they give you a discount code to give you discounts on the groceries so that they can track you. Certainly social media is tracking what we're doing. Our phone's tracking our location. Some ways this is good. If your credit card is being used by someone in a location where your phone isn't, your credit card company might flag it for fraud. So there's a lot more tracking. For the most part, that tracking is happening in the world that is not energy. The utility is tracking the energy consumption second by second in total, and even by some specific appliances. But the utility world, for the most part, has much stricter privacy rules about who owns the data, and the customer owns the data. Whereas in social media, the companies like Facebook feel like they own your data. So there is a disconnect between who's doing the tracking and who they believe owns the data and what they use it for. And the utility world is much more private and respectful because of different sets of laws and different culture than, say, the modern apps and social media we're using, where they follow you and track you, and they don't feel like you own it. They feel like they can sell it to companies who want to put ads in front of you and that kind of thing.
Yeah, and
So
I think that's the
be
key,
worried.
the idea that they feel they can resell the information. The relationship between a prosumer and the utility will be much more collaborative and private, it sounds.
Yeah.
I think that's correct. And as Michael was saying, there's a lot of emphasis on ownership of the data on the utility side and protecting that ownership to the customer, probably more so than in other private sector businesses. But the tracking of the data and the use of the data can be extremely useful in terms of energy efficiency, allowing what is called intelligent efficiency in the home for the turning on and off and control of appliances. The utility with much more sensor and intelligence can optimize the operations of the grid and transmission and distribution. So much more data being used by the utility side, but I think the protections are fairly good there.
So a lot of folks see a paradox in the use of information technology, and that is, of course, you have to power all of that IT in order to get this level of efficiency. Do you think that there is enough aggregate savings in our use of electricity generated by this information technology that we can actually create a more efficient and more equitable economy simply by measuring things and using it more efficiently?
Yes, I think that absolutely that information is a gateway to democratization, because information access and energy access and access to freedoms all go hand in hand. So I think we have more information, as long as it's in the hands of the consumers, the people who benefit, and not, say, just the corporations and not the consumers, then I think it can be a pathway to more equitable access to energy and less pollution, more efficiency. So I'm pretty optimistic about it. It certainly has its downsides. The IT sector itself is growing in its energy consumption. So there's energy required to provide the data that is used to save the energy. There are the privacy issues you already asked about. So this isn't a perfect system. But generally speaking, I think operating blind with the energy system, where we don't quite know what people are going to do, where, how, creates vulnerabilities. And if we have a little more information, we can anticipate better usage patterns, then the whole system can be more responsive.
Well, let me go back to another element that we spoke about a few minutes ago, and that was the electrification of transportation. And President-elect Biden has described installing tens of thousands of charging stations. But of course, a lot of the United States is still fossil fuel dependent. How can we make that switch to electric vehicles without raising our use of fossil fuels in the short term? And what do you recommend as a strategy for accelerating the move away from fossil fuels to renewables in those regions?
Well, I think that the primary focus should be on the mass deployment of wind and solar in the electric grid. Even electric vehicle charging stations in coal-dominated areas, studies have shown that there's still a marginal benefit to switching over to electric vehicles from gasoline-powered vehicles, even when the power is coming from coal. But the transition is taking place throughout the country, and I think that if we focus more on the mass deployment of wind and solar, that the transition to electric vehicles will take care of itself in terms of the environmental benefits.
Michael, did you have anything to add to that?
No, I think that's the key. Let's clean up the grid, and then that will help with the electrification and everything else. I will say that I've been thinking a lot the last few years about the need for mass deployment of charging stations and incentives for electric vehicles. I don't think those are as necessary today as I thought even just a few months ago, because the automotive manufacturers are really going to make this choice for us as they shut down their factories and production lines for internal combustion engines, and instead retool and make factories just for electric vehicles. It's already been announced by Volkswagen and others. So a lot of this hemming and hawing that people like me have done for years about the need to accelerate electrification of light-duty transportation might be irrelevant and moot, because the manufacturers are going to make the decision for us.
Also, I would add that the emphasis on electric charging stations as an absolute necessity for this transition is probably overblown. I have had an electric vehicle for several years now. I don't have a charging station. I plugged it into the electrical outlet that was in my garage, and it has worked just fine, and it takes a little longer to charge. But every building essentially has a filling station in it already, and we can make the transition adequately with the pace that we're going with the electric charging stations.
So let's talk a little about buildings, another element of the future that you call out in the book. And you didn't mention Stuart Brand, who's one of my favorite authors, idea that buildings learn and change over time, but you clearly believe both buildings and vehicles are going to be smart learning systems that optimize themselves in response to things that we, the users, do. How should we think about recasting buildings for greater sustainability? You know, the president described this as building buildings with tiny little windows or no windows at all, which of course is completely inaccurate. What's the future of buildings, and how do you think we should be trying to support rapid conversion to sustainable models?
Well, I think that buildings first are going to be more sustainable in the future in terms of climate change, sustainability, and such. But buildings are also going to take on additional roles that we haven't envisioned them in today. I think that buildings are going to become more health monitors, particularly for our senior citizens, in terms of looking for through motion detectors and other forms of sensors, looking for health problems for the occupants of the buildings. Many buildings that have minimal power needs during the day are going to be covered with on-site generation, are going to be essentially power plants for most of their time, interacting with the electric grid. And we're going to see buildings more and more become CO2 removal devices, both through planning and an urban forest being developed around our buildings, as well as synthetic removal of CO2 and filters and such on surfaces. So we're going to see buildings more and more become sustainable in that sense, as well as becoming more intelligent and responding to our needs, able to accept deliveries to a building, able to have tasks handed over to the artificial intelligence embedded in the buildings and so forth.
So how should we think in terms of the importance of subsidies for that kind of conversion of buildings? Particularly now after COVID has changed the patterns of work so much, should commercial buildings be a central focus of our energy policy, or are they a secondary concern?
My view from Europe is a little different, because in Europe and countries like France and Germany, they have very strict building codes at the national level. In the United States, our building codes are often at the local level. We don't have national building codes quite the same way. And these countries have used national building codes to achieve a lot of efficiency gains for new construction. Really great success in terms of energy consumption per square foot, despite the cold weather in the north or the hot weather in the south, like in Spain and that kind of thing. And so building codes are a pretty effective way to get the efficiency targets you want for new construction. At least I don't think you need subsidies as much as requirements and codes, and this achieves other benefits with air quality and safety and protection against fire and this kind of thing. So building codes for new construction is a good way to go. Then there's a problem of retrofits. We have 100 million homes in the United States already built that exist. We're building more as our population grows, and we have many more federal buildings and commercial buildings and courthouses and airports and that kind of thing. So retrofits might need some incentives or subsidies, whereas the new construction might just need codes. But these subsidies, if done the right way, can achieve multiple outputs in terms of avoided energy consumption and therefore lower energy bills per month for the occupants and better air quality and that kind of thing. And something that Roger and I saw with the local utility is that sometimes these incentives that are, say, weatherization oriented for retrofits are really good for the efficiency of the home, and they make the quality of life better for the people in the home, but they don't necessarily save energy, because it might be the homeowner was underheating or undercooling their home for years or decades because they could not afford to heat or cool the home to a comfortable level. But once you add weatherization, they can afford it. So their energy consumption stays the same after weatherization, but they are much more productive and comfortable and safe. So there's a mix of solutions based on what kind of building you're dealing with and what vintage it is and that kind of thing.
Well, so is it time for a federal building code in the United States? We see this with recycling. The 50 different states and all the localities don't do things the same way, it makes it impossible for people to reliably recycle something. Is it time for us to start thinking about national standardization across a variety of fronts?
We have some national standards for building codes as guidelines. The states have to adopt those codes as their state code, and so we have somewhat of a hybrid system. The idea of a national building code is attractive in some sense, but taking that right away from the states might be a big lift in this country at this time. It has proven easier to establish a national standard and then encourage the states to adopt that standard.
And one other thing I'd say is because the United States is so large, it's like basically a continent, the weather patterns are so different from one place to another, and the local resource is so different, and the local building materials, a national code might be difficult to implement here compared to, say, in the Netherlands, where it's a smaller, more homogeneous country with similar weather from top to bottom. So it might be a little trickier for the U.S. to do a national policy on that. As well as the United States, we don't like the feds telling us what to do locally, so there might be just resistance, as Roger was saying.
Well, we certainly are a country capable of arguing our way into the future. Let me ask, how has COVID changed some of your assumptions? Has it caused you to rethink the way that we should plan transportation and work in particular?
I think COVID will be one of those turning points in history, as the Spanish flu epidemic was in 1918, as the world wars were, as the fall of the wall was, and at the end of the Cold War in Germany. So I think it's one of those turning points in society where there'll be a before and there'll be an after. And we still don't know all the impacts, but clearly it's impacting energy in a couple important ways. It has dramatically impacted transportation energy demand for commuters. So there's half as much commuting going on, so less gasoline and diesel for our cars to get to work and back. And even greater drop in demand for aviation and jet fuels because we're not flying as much, not traveling. And a lot of that will come back, but not all of it will come back. And I think that's a turning point. Despite the really big drop in transportation energy demand, the demand change for electricity isn't that much. Electricity demand went down a couple percent in a place like Texas because of a little bit less industrial consumption. But for the most part, we went from using electricity in our offices to using electricity in our homes.
Sure.
We all have our devices and that kind of thing. And that's kind of an indicator of what we think the most high priority or strategic energy form is, which is electricity. Like we can go without the transportation a little bit, but we can't go out without the electricity. That's a sign of the future. And then the looming question for us is whether COVID will accelerate the energy transition or decelerate it. And it might decelerate the energy transition because we're so broke from COVID that we don't have money to invest in the new infrastructure we need, that kind of thing. But it might accelerate it because we want to build back better, as Joe Biden says, or we want to build things to resuscitate the economy. And as we build things, we'll build cleaner stuff. And I frankly think COVID might accelerate a lot of the transition we're seeing.
I agree with what Michael's saying. I remember I had the job about 25 years ago of establishing a plan and encouraging telecommuting in Austin, and worked on it for years and really never went anywhere. And to see telecommuting and work from home just suddenly take place virtually overnight has been amazing to watch. And I think Michael's right that we're in one of those major transition periods. And then some aspects, such as telecommuting, will be accelerated. I think it will be interesting to see what happens to the international infrastructure and supply chains and globalization, and moves to bring manufacturing closer to source and so forth. So some of these sustainable trends will greatly accelerate. I think that the reduction in fossil fuel use for transportation has been accelerated, and some of them we'll have to wait and see.
So all in all, you're describing an environment where we have sentient-appearing, and that's a phrase from your book, environments that are listening to and responding to us. Our travel patterns are changing and may have changed permanently because of COVID. Are we prepared to educate people to work in the environment that you are describing? And is that another area where the president-elect should be looking at new programs and new investments to create the people who will live and work in this world that we're looking at?
Well, retraining and education has taken on much more importance in a fast-moving, changing environment with automation and artificial intelligence. To some extent, the advances in artificial intelligence are making it easier to work in that environment because we're creating a technology that we can interact with as if it was another person. We talk to Siri on our phones and Alexa in our homes and so forth. On the other hand, it is becoming much more difficult to retrain people rapidly enough to handle some of the changes in the work environment that's taking place and the skill sets that are needed to deal with some of this. I think a new educational effort is certainly in place, but I don't consider myself an expert in that area, and hopefully there are other people who are working on it better than we are.
And I would say that one of the motivations for me and Roger to write this book is to reach some people and educate them at least on what we think about the future, and there are other means to do so. And an ongoing debate in the ranks of the universities where I sit as a professor is whether our job is to educate students or train students. And this is a little bit different. If you're training students, you're preparing them with very specific skill sets they can use for their jobs and careers right out of school. But if you're educating them, you're preparing them for the process of how to learn so they can keep training themselves and keep learning new skills throughout their lifetime. And I fall on the side that we really should be educating them because the skills they need for the next 20 years are different than they need for the 20 years after that. That the education makeup and that the workforce makeup will vary significantly at least once, but maybe multiple times throughout their working career. And we've seen that already. People have one skill set. They came into the workforce 20 or 30 years ago, and now what you need to thrive is different. And the younger workers have it, and maybe not all the older ones do. And yet the older ones have great experience. So how do we retain that? So I think there's a real challenge with the labor markets in the U.S., and energy is caught up in that with coal mining jobs disappearing, but artificial intelligence jobs for energy increasing. So we're watching that in real time, and I think we have a social justice obligation to ourselves as a society to help figure this out.
So let's return once again to the question of equity. Do you think that after we proceed through this transition, that there will be enough additional efficiency that we might see a return to something more equally distributed in terms of our wealth? Is the prosumer in a better position to get their fair share out of the system than the old-fashioned consumer?
It's kind of a philosophical question, and so I'll give you a philosophical answer because we don't know exactly, but my belief is that if you distribute energy access, that will have a democratizing effect on society and people's opportunities and will be good. And if you concentrate energy into the hands of a few decision makers or a few power plants or whatever it is, then you have a concentration of wealth and power and authority. So I have a strong sense that distributed energy, which is many more smaller systems as opposed to fewer larger systems, that the distributed systems will go hand in hand with democratization and equity. That it will mean less air pollution, more access, more even prices, that will pay the same for energy here as we pay in other states and that kind of thing. So I think it'll be good, but we don't really have analysis that lays this out super cleanly, so some of it feels philosophical.
Well, and necessarily so. We never know the future. We have to navigate our way toward it. Let me ask this then. Are there sectors in the economy that you think are particularly resistant to that kind of democratization of information?
Roger knows how to answer that because he's been talking to these sectors for decades. I'll let Roger take that
one. Well, I think there are some sectors that move faster than others. I mean, it was very difficult to move the automotive sector from its mindset around fossil fuels and gasoline over the years to electrification. And in the same sense, it's been very difficult to move the electric utility sector. In fact, in the electric utility sector, I think the movement took place not because there was a convincing of the electric utility CEOs and so forth, but rather the sustainable fuels of wind and solar became the cheapest alternative and the most cost-effective new source of generation, and that really moved the sector. not a real change in their basic philosophy toward sustainability, which is taking place, but at a much slower level. And given that, I think that you see the sectors that are moving quickly and those that are not as a result of the economy. The internet is putting a lot of bricks and mortar stores out of businesses and department stores and such that are not able to adapt quickly. So it's a mixed bag out there.
Maybe just I'll build on what Roger said on automotive, because Roger, you started speaking to the automotive sector, I want to say in 2005. And when I started to join you for some of those conversations or got your updates in 2007 and 8, the feedback was the automotive manufacturers are pretty confident that they got it under control. They don't need this utility executive from Austin telling them to go electric. And then their worlds collapsed when the markets melted down in 2008, sort of proving the model that what they had wasn't a really resilient business approach. Yet, nevertheless, they didn't really go electric anyway. And now their market's burning up again. And the electric vehicle manufacturers like Tesla are doing okay. So in some ways, Roger, you were too early for this and they weren't ready. But now they see it and they're making the turn. The companies that either were electric from the beginning, like Tesla, are doing fine and are really have the same market cap as the next 5 or something automotive manufacturers combined. And other automotive manufacturers that had made the switch earlier, and I'm keeping it Volkswagen, are going to be okay and better than the others. Now, Volkswagen went electric not because Roger was right 15 years ago, but because they got in trouble with their Dieselgate scandal of and cheating. So it was unrelated, but they got in so much trouble with their conventional business model, they had to change to rescue the company. And it worked out that change was the right thing to do for them.
History has a funny way of playing tricks on us. Well, I think this is a great place to stop. But it's an inspiring book to read, both from a strategic thinking perspective and simply to try to imagine what the future looks like. So that's The Future of Buildings, Transportation and Power. It's written by Roger Duncan and Michael E. Webber, our guests today. Thank you, gentlemen, for spending some time with us.
Thank you.
Thank you for having us.
Well, folks, check out The Future of Buildings, Transportation, and Power on Amazon, available now. We'll be back with another innovator interview on sustainability in your ear soon. I'm Mitch Ratcliffe, your host. This is Earth911. Take care of yourself, take care of one another, and take care of the planet. Have a great day.